Right, so hello everyone. The objective of this class is to discuss your tutorial number 4 because some of you I think have a certain problem regarding tutorial 4. Can you hear me and see my presentation?
Yes, Doctor.
Okay, right. So if you refer to your tutorial, I presume that you already read the first 2 or 3 pages. So we are going to go straight to the Gauss elimination. So for the Gauss elimination, you have to be careful. If let's say that you wanted to copy paste the file, the code that I have written in your tutorial, please make sure and be careful that you do not copy paste without looking at the the file itself. Now, so I presume that most of you already tried to do this tutorial. So I'm going to just to run the code line by line. Okay, so I'm going to delete the green font. Okay, so the first line here, this is quite straightforward. So you're going to clear the previous data, not the previous data, but the value that you have on the command window. So, okay, I think on the command window. And then the second line here, ask MATLAB to close all the figures, all the previous figures that you have obtained through MATLAB. So we are going to start afresh. And the third line here, this line asks you, not ask, but going to show this purple font, the sentence within that purple font. So this is the syntax. So the syntax, this DISP is the syntax for display. So you are telling MATLAB to display these words, the blue colored font. So this is the blue colored font. Sorry, not the blue, but purple. So purple colored font. And then you are going to provide the coefficient in the equation matrix form in the form of A. So A here is your matrix. So for example, remember that previously, just get my drawing tablet. So remember that previously for the class, we the common notation for matrix for a certain problem, a certain algebraic problems, we can represent it in the matrix notation. So bear with me. Right, so so if you remember previously in our class, in our lecture, we have shown how we can represent algebraic equations in metric notation. So for example, if we have, still not working, still working. For example, if we have A matrix. So for example, if we have three unknowns of x1, x2, and x3, so for example, if we have this metric notation, which can represent actually the value of, for example, if we have 3x1, this is from the previous lecture, negative 0.1x to negative 0.2x3 equals to 7.85, 0.1x1 plus 7x2, and 0.3x1 minus 0.2x2 plus 10x3 equals to 71.4. So this, we have three equation, algebraic equation, and this algebraic equation, if we try to convert it into metric notation, it would be something like this. 3 it's actually this x1, x2, x3. This is square bracket. So in the MATLAB program that we have, we are going to write, or you are going to write in the tutorial 4, we are going to insert the value of the coefficient A in the matrix form. So we are going to input this particular coefficient A. So this is A, and also B. So this is B. In this line 5 and 6. And then you are going to specify that n is actually the length of B. So which is actually n is the total number of unknowns, or it actually represent the number of equations. So here, for example, if we have, since we have 3 unknowns, therefore we are going to have 3 equations. Therefore, the length of the matrix, which is n, is equals to 3. On line number 9, okay, line number 10, this is actually a function, embedded function in MATLAB, where we can start a stopwatch timer. So this is actually, you can actually delete this, or you can, it's up to you. It's up to you whether you wanted to write it or to use it or not, because this is just a stopwatch timer to determine how fast the calculation will be. And the first thing that we need to do, so if you remember that in order for us to solve a certain equation, a certain set of equation, algebraic equation using Gauss elimination, we need to transform A into upper triangular matrix. So upper triangular matrix, if you remember, is where we are going to have, for example, a certain number. For example, this is just a random number, not x, because I don't want you to where you are going to see, for example, A, B, C, D, E, F. This becomes 0. So this would be the upper triangular matrix. And the reason why we wanted to have an upper triangular matrix is that at the end here, at the n equals to 3 here, we can substitute directly to the value that we get for B. So after we have obtained that, we can then back substitute the value into this second equation to get the value of x. So this is x3 and x2, and subsequently we can substitute it into the first row to get x1. So line this the next process would be creating an upper triangular matrix. So line number 14, SS equals to 0, is actually correspond to the space. Sorry, it's the state space model. SS equals to 0. So SS is actually is a syntax. Space state. It's a syntax in MATLAB where you are going to assume at initial time t is equals to 0, or before we initialize the system, everything in the system is equals to 0. So meaning that SS is actually this is the correct, not the correct, but this is actually another representation of SS, of space set system. So A, X, B. So this is a representation of the matrix value here. So this line here denotes that at the initial time, everything in the matrix is equals to 0. So this is, if you remember before, if you refer back to the tutorial that, not the tutorial, but lecture that we have done in class, this is actually before the first modification. Remember that we have A to 1, A prime to 1, and A double prime to 1. So this is the first modification. This is actually correspond to before the matrix is modified, or before the matrix modification prior to the pivoting of the element. So SS equals to 0 is actually correspond to this, where we are assuming that at that time, at the initial time, everything is equals to 0. So this is a syntax for MATLAB. And this line here is actually a forward elimination where m times n is actually I times j. So j here is the column. So if we try to move this, so j minus 1, sorry, equals to 1 until n minus 1. This is actually the column. And also the row. For example, it says that it represents that for column 1 until n minus 1. So if you remember here, if you refer back to the upper triangular system, for example, n here is 3. We are going to pivot, or we are going to change the system to upper triangular system only up to here. For example, only we wanted to change everything, the element here, only from 1 and 2. So 2 here is actually n minus 1, which is actually 3 minus 1. So we wanted to keep this element because we wanted to know what is x3 as we substitute directly. So that's the meaning of line number 15. And then it says that if ajj is equals to 0, which means that if the element is 0, then we are going to pivot the row. So for example, if we have something like this, so this is just an example because I just make it up. This is just I just make it up equation for this particular session. So for example, if we have this kind of matrix, so 5x2, 3x3 equals to 12, 2x1 plus 6x2 plus x3 equals to 2, 3x1 plus 7x2 plus 2x3 equals to 1. So this is, please do not solve this because I don't think that you can solve this. I just make this up so that you can see how we can apply the pivoting procedure. So for example, in this case, this element here, we're supposed to have another element here. So this element here, we denote as, it's actually AJJ, which is A11. So A11 here is equals to 0. So remember that in order for us to factorize the second line, remember that we are going to factorize the second line is equals to 1 divided by A11. So A11 is actually A11. This, I don't want to actually confuse you. So A21, A11. Since this particular, in this particular case, A11 is equals to 0, therefore we're going to see that the denominator here is 0, and we cannot really have a case like this. Therefore, what we do in our second line, the 17, the line number 17, we are going to pivot the row. So here we are going to pivot the row. Therefore, the first line will go to the second line, while the second line will go to the third line. The first line. So this is how we pivot the row. And then for the subsequent row of m plus 1, so for example, if we look at this particular row, we will see that the factorize is 3, 1. So a 3, 1 over a to 1. So since a to 1 here, it's already changed. So this is the first modification. Since we already changed it to 0, we will see actually we're going to pivot it again. So since this is equals to 0 because we already changed the row, then we are going to pivot it again. So we are going to continue with line number 17. So continue with line number 17 until the value of the factorial is not 0. So this is for subsequent, if I'm not mistaken, this one is for 4 by 4 matrix. So after we end it, so starting from line number 24 until line number 29, we will actually see that we are going to change the value of the element. So B here would be the element from J, the column J, until at the end. For example, until at the end of that particular row. So C here is actually this. So we are going to denote this as B and C. And also, we are going to say that A is actually from the value from M until the end of the line here, which is, if it's 3, therefore we can put as 3. If it's a 3 by 3 matrix, so we can put as 3. And not put, but we can identify that the double column here, the column here would equals to 3, and then B here, which is this particular value here, will actually equals to the column vector M. So this is actually a repetition because it wanted MATLAB to see that instead of using INJ, we are also going to use M and N to signify the column and also the row. So this is actually syntax for MATLAB. And I'm not really sure if you have read this particular lecture. So the next process would be the forward elimination. So forward elimination, you will see that for that particular line, the first line of the forward elimination, this particular syntax means for the second modification, or for the second procedure. So this is actually just a syntax, meaning that we are going to have another procedure. And this procedure is actually forward elimination, where we are going to have this FSC means factorize. So factorize is equals to the value of this. So this is FSC and AI plus 1J with AI. I don't think so. It's I plus 1J. Sorry. I plus. So this one is actually AI plus 1J over AJI. So this would be a representation of the forward elimination, where we're also going to take into consideration not only the element in the A coefficient, but also the element in the B matrix. So this is line number 34 stands for. So we are going to end it. Then we are going to state that this is, we ask MATLAB to store it, and we are going to see that this is the second part of the metric. So what you're going to see is actually like this, something like this. So SS equals to 0, and you're going to see everything here is 0. So this is the syntax. And then after the forward elimination, the pivoting forward elimination. So this is where you have the forward elimination. You're going to actually have the process of where you have the value, for example, D, E, F. So this is this is B1, B2, B3. And after that, we are going to ask MATLAB to store it as SS plus 1. And this actually corresponds, if you refer to the example that we have done in class, this is actually correspond to the step that we have done manually. So the factorization, and also if we try to subtract it in order to make it as an upper triangular matrix. And the next step, for the next step would be the backward substitution SS plus 1. So this is So for the backward substitution, for this particular line here, I just refer to this. So if we refer back to this particular value, this is the end line or the end equation. So remember that if we have the end equation, so this is the first equation, second equation, and the third equation, where third is actually the end equation. So for the end line equation, we can actually get the value of x3 directly. So this is the syntax for to count down from n minus 1 until 1. So this is from 2 until 1. So if you try to do that, you will get first you will get the value of x3 here. So this is x3, and then you're going to substitute x3 into n minus 1 and also 1 equation and coef sum. So if we try to sum it together, all of it equals 0 in order to get the value of x3. So it's actually this corresponds to this line here. So this is actually, if you want to see in detail, you may, but it's a bit complicated. It's actually a syntax for you to obtain the value of x2 and also x1. And then you will then display the output, where this is where we are going to stop the TIC function previously. So this is when we try to introduce the function, and then TOC is where we are going to stop the timer. And then line number 49 is actually we are going to show the upper triangular form of the matrix, and also to display the value of A and the solution of the matrix of the equation as X. So just right. So if we try to run it, and let's say that we wanted to solve this equation here. So what we need to do is to input the value in the matrix notation. So 3 space negative 0.1 space negative 0.2. This corresponds to this line here. Same semicolon 0.1 7 negative 0.3 0.2. So every time we put a semicolon, it means that we are going to have to continue with the next row. So semicolon, another row, semicolon, another row. So 2 and 10. And the column vector, the right, would correspond to this value here. So it would be 7.85, 19.3, 71.4. So if you try to do that, you will get actually the solution of the system equation. X1 equals to 3, X2 equals to negative 2.5, and X3 equals to 7. So if we try to compare the one that we have done in class manually, it seems that we got a similar value. So as I mentioned previously, if you refer back to your exercise, so just go to exercise tutorial. For line number 1, the code shown previously is 4 unknowns with A is 4 by 4 matrix. Modify the code to find 2 unknowns and also 3 unknowns. Actually, a 4 by 4 matrix would be similar to 3 by 3. The only difference would be if it's 2 by 2. So if you have a 2 by 2 matrix, what you're going to do is in the forward, when you are creating an upper triangular matrix, you are going to pivot it once, only once. So instead of having continue here, you're only going to pivot it once because you only have 2 rows. So that's the only difference. So that's I'm going to leave it to you to discover, but I don't think that I'm going to ask about this in your exercise. Therefore, you wouldn't need to submit it to me. So no need to submit it to me, exercise number 1. However, you need to solve exercise 2A, B, C, and D. Now, Irfan told me that some of you might have different textbook, the different edition. So can you use the one that Irfan have shown or Irfan have shared with you? So you need to do equation MATLAB A, B, C, and D. Any question? Can you try to do that? And then maybe I'm going to have another breakout room so that you can show it to me and ask me question. I have written in the text in the chat box the link for Google Meet that you can use if you wanted to ask something or you wanted to show me your MATLAB code.